Hi guys, can you hear me? LG means let's go, huh? I'll give some disclaimer that I may eat food in between, I guess, like once or twice I may eat food. And also, I may not be able to solve even one problem. You guys should watch at your own risk. And I'll do it for 4 hours because I told I will. And then, and then I need at least 10 viewers to start. I applied oil. In general, I don't apply oil to my head, but I applied coconut oil somehow yesterday. But it is part two, it's continuation of the previous video, so I'm not changing the title, okay? And yeah, light gas, it is the same part of that video, that's why I'm just keeping the same thing. I slept and I just woke up. I just woke up at 3 o'clock or 2:30, I think. Why don't I look that good? Like, should I, maybe I should trim my beard, but let me just clean this laptop a bit. I used cloth this time. Yeah, my camera is also fine. Like the video too, guys. I'll just try to solve the same problems that I was solving last time. Fine, that's because of my hair. Like, if my hair differs, I look different. How to adjust my camera though? Thought that I was dreaming when you said you. Maybe this is better. Right. What do you mean leagued? Pradeep. I have a good MacBook, but somehow it gets slowed down. I have like max 4, I guess. We have to solve problems. What do you mean room tour? I have Apple M4 Max Pro. I don't know what it is. Maybe this zoom is good enough. So guys, we need some likes. If I get 5 likes, I'll just start solving problems, and you guys also should try your best when I'm solving problems. Where's my pen? I have my pen too. Should I wear specs and look like a good nerd? Thought that I was dreaming. There's no Mac giveaway. Yeah, we have likes too. L specs. I'll remove them. I don't wear them for long somehow. I just remove them automatically. You guys should try to understand something from the title. I think we will try six, at least 2600 or more. Last time I tried, I was not able to do anything, right? But let's try again. Same things. What are the things that I've opened last time? I've opened Zod Durable Array. I think no, not this. There was something else. This was that stupid problem that I tried last time. Not stupid, but somehow I was not able to. I misunderstood the problem entirely. It's a cool problem, it seems. 7 quadratic jumps. Where is the other problem that I have tried? I think there is some other problem that I have tried, right? This is one thing. Have I tried this before? I have solved this problem live sometime. I have solved this problem, but I was not able to implement it. But I solved this problem once in long back streams, like 4 5 months back. I have solved this. I can remember the video too if I try to, but I can remember the video if I try to. But yeah, we're going to read many problems here, and then we are going to try many problems from here. Like we get them or not, we're going to read most of them and we are going to try most of them. Okay, this is the one I have tried last time. They call it cool problem and I'm not able to get that. So what I will do now is, this was tried and then I stopped on that. This, I tried something, I was not able to get anything, and I'm going to try again the same one for a while. Okay, I'm going to try the same thing again for a while and then I'll move on to the next problem so that it won't be that boring for us. Trying the same thing again and again. I got some food, so I may eat in between, but Teja, thank you. So guys, what you should do is like the video, and then you guys should also try to think of the problem. Okay, you guys should also try to understand the problem. Whatever the rating is, you should try to understand the problem. You should try to think, try to do your best. I need at least 10 likes. Okay. I thought that I was dreaming. I thought that I was dreaming when you said you loved me. Are you guys there in the chat? Why is it so empty? So, see, it's about thinking a bit deeper, okay? In CP, most of the times I used to think deeper long ago. So, this is the problem. See, you guys should be smart enough to find the problem. See here, 2187D. Cool problem. Or just go to 2600 and then open like how I have done it. Or just see my screen. Maybe I'll just make it a bit bigger if you guys want to. This is not helping. Yeah, maybe this helps. Guys, for now, let's just focus on this problem I have tried before. This one I will try for 5 10 minutes and then I'll move on to some other problem. Okay. So let's try this again. So given a binary string, we are able to generate a sequence by doing plus x. Last time what I have done was I have done a lot of things on the same problem. I was trying to see all problems are about simplifying things. Like you have to think, how can I see it in a simpler way? How can I say it for what it is? Like all problems are about that. But this one seems a bit difficult because see, first you have this generating array and then you will find its sum, and then you are given a incomplete binary string. You have many ways to fill that up. After filling that up many ways, you want number of distinct values that can be formed. I've seen something that I thought that I was dreaming when you said you loved me. I've seen something that uh, only once will flip it, or if you try to see number of odd ones or even ones, and I have seen that if you see from this one to that one, it will be like quite simpler. Like if you try to see two ones, I think it will be quite simpler is what I have seen last time. Maybe I'll open that file. So this is what I have seen, that from this one to that one to this one, like if you see from this one to the next one, if you see two ones, you can see that if the value is z here, it will become y minus z because that's what is happening, and then plus x plus x, so on. So if we try to see, it is like z will become After two flips, z will again become z. That's why I'm trying to see two flips. So whatever this z is here, that will become just z. And what happens to the remaining things? It has been y minus z, y minus z, y minus z, y minus z, and then here it will flips, and then it will be z, 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 and so on. So after two flips, the value will become z again. Whatever the here z was, the value will become z. But because of this zeros, you will be added plus x plus x plus x plus x, and then because of this zeros, because a flip happens here, all these zeros are like minus kx. Number of zeros that were there, that much of minus x will happen, and then number of zeros here, that much of plus x will happen. So that would be your value here. But the problem is solvable for what? It is solvable for the summation of all these things, the summation of all the values, the summation of CIs. We want number of such distinct things, like somehow, are they all different? What I mean by like, but if they are all different, then the problem is just two power question marks. But yeah, they may not all be different, but maybe only few things are achievable somehow. You can see that you can see that the values are always okay. In between you have some weird things, but the values are always, this is always zero, right? So this is always zero. I mean, if the initial value was zero, initial value is zero, right? So what I'm trying to say is, after two ones, y will be gone always, and y will only exist here. After ones and zeros, only there you will have y, and then again y has gone. So number of y's to the final answer or to the final summation itself is number of zeros after ones, after odd number of ones. Y into L of 0, left side of 0. So I think if you see here, y's are not occurring that much. So mostly it is just x. If you see the final values, it's just x varying, and if you see the summation, it's like x into k plus 1 by 2. I was telling like we have two different of k's, and then you have many things afterwards. I thought that I was dreaming, and you said you loved me. So if you see in terms of y, the value with respect to y will just get fixed fixed by number of zeros after ones, and after that, how will the value of x gets fixed? How will the summation gets fixed? Is there something nice among this plus x plus x plus x, and then I mean this plus x plus x plus x plus x, and then minus kx, and then plus x plus x plus x plus x, and then again here what happens is just flip, one more flip, and then so it's like with once you're having plus x plus x plus x plus x, and then flip, and then plus x plus x plus x, and then flip, and then plus x plus x plus x plus x. So if you're trying to see those things, like where you have a value, you have plus x plus x plus x, and then you have flip, and then plus x plus x plus x, and then you have flip plus x plus x plus x, and then you have flip plus x plus x plus x. That is lame. I'll open my food. I'll try to eat it a bit. So while eating food, I won't try the same problem, because that will be like less concentrating, right? So I will try to read another problem while eating food. Is that fine, guys? I know some people will leave comments like, "Is it lagging?" Okay, so Kailash Chaudhary has given me permission, so I can just. In Swiggy, I added cooking instructions like make it spicy. I don't know if they honored them or they just. Okay, let's try to read this problem now. You guys should be able to read so many difficult problems and give your best. Okay, this I already read. This one we have read. We understood the problem a bit. What is the problem? You have a transformation and then you have a definition f of r equals to sum of the values, and then you want number of distinct values that are formed when there are some question marks, and you can replace the question marks with 0 or 1. Okay, you guys got the problem right. One thing is very clear. It's like the summation of some x's and some y's. Y's will be y into number of ones after zeros, and x will be, I'm not sure if there is a pattern in x here. It's plus x plus x plus x plus x. And then what happens? Some length, and then you got minus length of that. And then they are all getting cancelled with every x. Oh, they're all getting cancelled. If you're trying to see the summation. Okay? And then you went somewhere. Now you flip again. Now you grow from there if you try to see the summation. And then once you flip, you come back down. And then once again you flip, you go back up again. So I think the sum is almost the summation of all this case. That's what I asked just before. Will the summation of all this case will just be one case? I think it's always this format. Y times sum L0 plus x times sum 1 plus 2 plus 3 plus 4 and so on. Or minus 1, minus 2, minus 3 and so on. Because you guys see that. Let's say 0 started here. And then you have plus x plus 2x plus 3x plus 4x plus 5x standing over there. And then all of a sudden minus kx will happen. Now if you try to see the summation, these two have been cancelled, right? And then again you increase plus x plus x plus x. This will get cancelled, this will get cancelled, this will get cancelled if you're trying to see the summation. And then we go somewhere. Okay? Now you flip. And then you're doing plus x plus x plus x. Now after this flip, you have this thing 0 plus x plus 2x plus 3x up so on till here. Now it's again started growing. So you guys see, even though it's complex, there is something simple in here too. Do you guys see that? The final summation is quite simpler. We're able to say that the values of x will only be like, the summation of x will only be like x, 2x, 3x, 4x, 5x, and then it may flip. That means the summation is, this thing is coming down, coming back, and then again it may go, it may come back, and then again it may go. So I think it is always this format. This is the f of r. F of r is just this symbol. So whenever you guys try any difficult problem, all you have to try is not how you can solve the problem. All you have to try is how you can simplify something. Is there something that is getting simplified here? You have to keep trying to think or trying to look for that. Ordered Malabar biryani. I'm eating biryani 2 times all the time. I'm staying in a 1 BHK, but I'm not cooking anything. I'm just eating from outside. You guys can smell it though. So, do you guys see that? When I tried last time just to solve the problem, I just didn't say it that easily. I was just trying to write the equations. I was not trying to see how I can simplify that. But now, when I try to see how I can simplify that, it's being quite obvious. X, 2x, 3x, 4x, up to so on, let's say some 7x. And then minus 7x means, if you see the summation, this minus 7x has been cancelled. And then minus 6x, this has been cancelled. And then minus 5x, this has been cancelled. And then minus 4x, this has been cancelled. Now what happens? I hope something doesn't double here. So now you flip it. So if let's say minus 4x has cancelled the plus 4x, now when you flip it, you add plus 4x. So the plus 4x will come back. It's not 3x doubling. It's always maintaining this chain. Like I was trying to see if 3x will double because of the flip or because of the boundaries. But now, whatever the minus 4x that has been gone, now it becomes plus 4x, so it will come back, and then plus 5x, plus 6x, plus 7x, and so on would be the values. And then whatever the value that is there, that will get flipped. So then the summation will be removed and then keep coming backward. So you guys see, when I try to see how this thing is can be simplified, here I got a value k. Okay, here I got a value k, and then I'm telling the summation will be that. But now I have an even simpler value which is only being dependent on number of zeros here. Okay, now we know that it is just 1 plus 2 plus 3 up to so on, right? Now what would that value be? That value would likely be minus of number of zeros here, plus of number of zeros here, minus of number of zeros here. It's just number of zeros after even number of ones minus number of ones after odd number of ones, x times that. It's just that. So this value is being fixed if that value will be fixed. So this is definitely right direction to the problem, right? Simplifying something is obviously right direction to the problem. Okay, now let me read some other problem because we can't keep trying. Have you guys gotten something at least here? Prepare for that maybe. Oh, no, I'm also seeing the summation and then they are getting cancelled. Have you seen that clearly, Pradeep KR? Maybe I'll just talk to you people while I say, have you seen that summation is just being plus x plus 2x and so on? If you have a FANG interview tomorrow, look forward to it, bro. Look forward for it and try to think for yourself how can you do better. And if you do bad, try to see how you can do better one more time. Having an interview is good, I guess. Like people don't get interviews that easily. There are so many values, but the summation is always for x just this line. And for y2 it's quite simple. Y's only appear from this one to the next one, and they appear like 1 2 3 up to so on number of L0 number of 1 times. So if you see the value is just y into number of L0 things, let's say odd zeros as something, y times number of odd zeros plus x times number of odd minus even k into k plus 1 by 2. So whatever I wrote last time, this is just the answer. This is just the answer, but I wrote it only for one thing. And then I also involve z. Keep z as 0. See this shit. Answer is just this one. Now you know very well. Now you know very well something about the problem. Now you have to think with respect to x and y values, how will this differ? Yeah, Kusha, I know that it's expert now. I think you gave sometimes like timelines of problems, is it? Maybe no. Maybe you did. Yeah, you did. I remember. Well, so guys, this one we didn't make much progress at all. We made progress like it's the algorithm some n into 2 power 12 plus 2 power 12 square or something like that. This one we actually saw that it can be quite simplified. Now we have to think of how can you still get number of varies that are happening here. Let's read this problem. You guys should realize that you should be able to read many problems and try them for 5-10 minutes. We didn't get the problem here, we only got half the problem. We only got how to find f of r, but then we have to solve the problem further, right? We have to simplify things further. I will implement if I get the solution. I didn't get this one, I didn't get this one. Now I'm trying to read some other problem, okay? You guys also should be able to read many problems. You should never be scared to read a problem. See, with CP, you have to just develop some good habits. Like in general, you have to realize that fear is like a real thing that makes you not solve a problem. And if you be optimistic, you will solve much, much better. You should use CP to just learn these things because you can't learn something without practically realizing it. Oops, I closed the problem. Yeah, this is the one we are reading now. I think I should read faster. You are given an array of n integers. The array is PQ xorderable. If it is possible to rearrange it such that for each pair I comma j that satisfies this, the following conditions must be satisfied after rearrangement. A XOR P less than or equals to AJ XOR Q and A XOR Q less than or equals to AJ XOR P. See, this is also a nice problem, right? If you guys think of it, there are logical elements here to work on. Okay. If you believe in golden rule, it's not like you need to know a topic, you need to know an algorithm. It's about logically solving this problem. Oh, this is being quite. See, if you see the structure of the problem, you're given some weird definition. An array A is called PQ XORable if this fucking condition satisfies for all the pairs after a rearrangement. So this is quite complex. That you have to realize that things can be quite complex and then they will be simplified. That's what these problems are all about. This is a definitely triable problem because you see, this P comma Q XORable will be so simplified that you can actually calculate number of such pairs in some other array that makes this array A XORable. Do you guys see that? You can find number of pairs that can make this happen. So you can definitely work on what pairs will make XORable happen, and then you have a set. Among that set, this is not an array. This is just a set, and then among that set, you will find number of distinct indices that will make it happen. So the problem immediately gives away that this is simplifiable. Otherwise, you can't compute number of pairs, right, that easily. So you have a task now. How to simplify this? What it means if this satisfies for all the numbers. Think, guys. A XOR P less than or equals to AJ XOR Q, and also A XOR Q less than or equals to AJ XOR P. Maybe most of the arrays are not orderable at all. Maybe the arrays that are orderable has a very specific property in them. Maybe every array has some P comma Q orderable pair. That makes the rearrangement possible. Let's look at these two arrays. One array is A XOR P, let's say. The other array is A XOR Q, let's say. If you see those two arrays, okay, let's see those two arrays, let's see those two values. What does it mean? If you are trying to see A XOR P and A XOR Q, what does it say? For any value in this array, all the values after in this array should be greater than or equals to. And for any value in this array, all the values here should be greater than or equals to. See, the arrays P XOR A and Q XOR A, they themselves need not be increasing, but they hold the property that for this, all these are bigger. For this, all these are bigger. Does that make them increasing though? Have you guys understood this problem? Have you guys understood this problem? I gave a warning. I'm sorry for the sounds. I gave a disclaimer that I may eat food in between. I'll finish this quick. Sorry. But try to think about the problem. I know I'm making sounds. I know we should not make sounds while eating. Think about the problem though. Are you guys able to think of this problem? Have you guys understood this problem? Have you guys understood that there are two arrays? One is A cross A XOR P and the other is A XOR Q? See, the problem is quite complex. That makes it better because that means it's simplifiable. Whenever a problem is quite complex, you have to wonder like how can I simplify this? You have to take it as a challenge and not like it's definitely not memory. You guys can lie to yourself by telling maybe it's some algorithm I don't know, maybe it's something I don't know. It's logic, it's pure logic. You know XOR definition. You know what a rearrangement is. You know arrays. Most of the times you guys just lie to yourself if you tell it's something I don't know. There is no segmented that solves the logic that's here, right? So you have to try difficult problems where there are actually logical things to solve. Now let's think of this problem. Both of them should happen. Let's come from behind for these two arrays. Okay? If you see the last button element, the below value is bigger than that. That below value is bigger than that. Okay? So you have that is bigger than this and this is bigger than this. Now let's see the other thing. For this, these two are bigger than that. We can try to see it in many ways. We can try to see both the arrays in the same line itself and then sort them and then see that. See, 0 comma 0 is always there. 0 comma 0 is always orderable because you can just rearrange the array to be increasing. Yeah, in the same way, x comma x is always orderable because you can just rearrange them. You can think of what it means if this thing satisfies for a pair a comma j. Can you say something? You guys should try. You guys should try to think. Try to say something you can say. It takes time, but you have to try. It won't be too difficult. It's about simplifying things. Let me see that in two arrays itself. You have one array here. You have another array here. Okay. I like these two color combinations. Like good flag they would make. Now I'm drawing with left hand. Okay. I'm about to finish my food. It says this is greater than this. Okay. This is greater than this. And then this is greater than both of these two things. Sorry, this both of them are greater than this. So because this is greater than this, which is greater than this, also this will be greater than this. So there is an ordering even in this array. I was just trying to check that. What is that ordering? There is no ordering between these two, but and then let's try to extend it a bit. I'm eating non-veg, by the way. If there are any vegetarians, those are too sensitive. Maybe I can just mute. Think of it, guys. We can solve this problem. We may solve this problem. All these things are bigger than this, okay? And all these things are bigger than this. That just means that it's obviously true that this array should be increasing. Not strictly increasing, but if you take this array, all the things after this except then immediately next one should be bigger than that. So what can you say about such an array? Okay, this thing has been clearly proved. This is bigger than all these things, and in fact all of them are bigger than this, and then all of these are bigger than that. So even this is in almost increasing fashion, not exactly increasing. We haven't applied any properties of XOR yet. All we have done so far is given two arrays. One is pigs or a, pigs or q, and the condition they set among pairs. What does it mean? Thought that I was dreaming, you said you love me. The start of nothing. Ooh, I can hear you. See, it seems like we are not able to solve it. If you guys try properly, maybe just one simplification solves it. There. Isn't it boring? How are you guys staying? Is my internet stable? See, x comma x works, right? X comma x works, right? Because you just sort the array. See, you should believe that it's solvable because you can finally compute number of pairs that makes this array exorderable. So that means you can simplify and you can find it. So it's a good problem to work on. Okay, you guys should keep trying this. It's a good one. See, x comma x is both the values are same, right? So if if for x comma x both the conditions are same, and now you want an ordering where x or x less than or equals to h or x. See, there is a way to rearrange them. Okay, uh, you can rearrange them, or you find Pradeep, you can rearrange them. Maybe that simplifies the problem. Maybe not. Okay, is this implies and implies? One thing we have seen is that one thing we have seen is that see how am I drawing with my right hand, right touchpad? I mean, one thing is clear is that let's say this be the array, this be the last element. We know this is greater than this. For some particular value, we know that this is greater than this, and all of these are greater than that. We also know that all of these are greater than this. So, except for this and this, wait. Also, this should be greater than this. Except for this, everything here should be greater than that. So, what can you say about this thing if for every index, except for the next thing, everything else after that is bigger than that? Can you say that it's like an increasing array? You can only do some adjacent swaps. Is that it? It's like for every index, number of inversions. I mean, number of things less than that should be at max one. There cannot be two things less than that after that. So does that make it almost increasing with little bit of swaps? Oh, I just removed the straw. Now there is no straw. See, with this structure itself, it says once you apply XOR with P, the array that forms and the array that forms with Q are almost equal, except for the fact that because both of them are almost equal to the original array A, except for the fact that some of them are swapped. Here, maybe some other two things were swapped, and all of them hold the condition that for this, all of them are bigger. That condition should be hold. That condition should be held somehow for everything. Okay, we can simplify the condition that this is bigger than this is a necessary and sufficient condition to say all these things are bigger than this. What do I mean is all these things are already bigger than this. So I can just say this is bigger than this. That says all these things are also bigger than this logically. And I can say this value is bigger than this. So we are simplifying the conditions into all these things bigger than this can be simplified as this bigger than this, which gives away all these things are also bigger than this, which gives away all these things or bigger than this already happens, and all these things bigger than all that will already happen. So we can just say, instead of saying all these things bigger than this, you can just say this bigger than this and this bigger than this. Now you can simplify it in that way. So what I'm saying here is, you can just simplify that into, you can simplify that into, but still we don't get anything with that. For those two arrays, you can just simplify that. Let's say I'll call it PA of I less than or equals to PA of QA of I plus 1, comma QA of I plus 2. Similarly, QA of I less than or equals to QPA of I plus 1, comma PA of I plus 2. Instead of like all the pairs, we can just simplify it into this, but still we don't get anything. There is something that is simplifying things a lot, but maybe it looks like something because minimum of these two things is always fixed. Maybe minimum of these two things is fixed. Maybe if I assume the assumption that I had one assumption, sort the array A, and then you can at max swap two things. Not the array A, sorry, not the array A. Sort the array A XOR P, and then swap at most two things. Okay, that doesn't connect array Q, but indices connect array Q. So what does this mean? Take an array A, XOR it with P, then the sorted array you get should only swap at max two things. We haven't gotten anything yet. I'm just growing it. I'm just not cutting my hair. Hi Mohit, what are you doing here? Wow. Has done something an year back. Are you guys tired already? You guys should not be tired. You have to keep trying. Only 1 hour has passed. Yeah, we can look at that bit too, but before doing that, I'm able to say what I'm able to say. Okay, I'm able to say a lot of things. Some things we are able to say, which is like, you see this. There is one thing. It looks like if you just see one array, you have this statement that all the things except the next one is bigger than this. Okay, all of these things are bigger than this. Thought that I was dreaming. I thought that I was dreaming when you said you loved me. How can you see that? Hi, Kuldeep. Yeah, I'm reading the comments. You talked about my hairstyle, and Yeah, I will live stream contest also, but see, if you think you're gonna only learn something when you solve something, that's stupid. You don't learn anything when you solve a problem, okay? You learn it when you try, I guess, or when you try to spend more time. I don't know why you think so. I don't think it's time waste for me though. The thing is, you have to try. You should also try this. Like, why are you not trying? You should try. There is something. Maybe we can see it a bit simpler. I was trying to see if I look at maximum of adjacent elements, then can I say that that is increasing, and then can I say that uh, okay, we have one thing definitely. If this thing is almost sorted, we know that everything greater than I plus 1 is bigger than this. Can you say this with that logic? Can you say, see, you have so many problems here. I don't know why you are thinking there are no problems here. See, we have one simple problem here, uh, which is I'm trying to see that problem. I'm trying to solve the problem, which is if all these things are greater than this, and that happens for all the array, can you say the array is take a sorted array, swap at max two adjacent things, and then swap somewhere else two adjacent things, and then swap to somewhere else two adjacent things? Is this true or not is one problem that I am trying to see. So even if you don't solve the whole problem, in solving these difficult problems, we have something to think on here. I'm trying to think on this problem, and why do you think like it's a dead end for us? Like, if it's actually a dead end, then I won't stay on that problem, because this was like a dead end for me, so I haven't stayed on that problem. I just moved immediately. Here I simplified few things, and then again I'm not stuck there because I don't want to waste time. But it's only time wasting for you if you're not trying to think the problem, and if you're just trying to see something for visual entertainment maybe. This is a problem you can think on, right? See, the swaps are disjoint swaps. You cannot swap these two things and then these two things, because if that happens, two things will move. So what I'm telling is, in the sorted array, an element will at max move once from its position, cannot move twice from its position, is what I'm trying to say. How can you prove that? Let's try to say, let's try to come from here, this side. I think it's likely true. So that makes this sorted array, that makes the array that says something about uh, eggs or p and eggs or q maybe. I'm telling you, you have to try on your own. You have to try more, and you can definitely say such things. Guys, let's try this problem. We are going somewhere, I hope. See, is this true? It seems to be true. Let's try to see maybe inductively from the behind. Uh, let's say the first time something in the sorted array has moved two elements after. Okay, let's say that has happened. So my assumption is that in the sorted array, an element can displace from its position at max once. Okay, what does this leave? This will leave some disjoint swaps. See, applying such logic, saying such logical statements, and then working on them is all about problem solving. You should be able to say such things like, okay, can I say uh, an element will at max displace by one? And then can I prove that? So it's not like you get a great idea. It's like how you work on the problem, how you build things, like how you prove things, how you get simplifications, and then how you work on them further. Okay. And if you're doing this, you're automatically improving your logical ability. If you're trying to prove something, if you're trying to make some logical statements, you're increasing your logical ability, like, right? You're increasing your ability to argue. So why do you think it's time waste when you don't solve a problem? I don't think it's not at all time waste. And you can argue more, and you can argue more logically when you're not able to solve the problem and you're still able to dig into the problem. If you are completely shut down, I mean, if there is no way to think, then you have to stop. Then it's not helping. But if you're able to work on few things, if you're able to think some things, I still haven't come to XOR. I'm still trying to see. I'm still trying to see the logical implications of two arrays satisfying this uncondition, and then I'll try to see about XOR because this itself has something in that. This itself has something. It's like under P or under Q, both of them should have similar transformation to the array A, almost similar transformation to the array A, such that in A XOR P, once you reorder them in some way, there is a reordering in which if you swap some adjacent things, you get A XOR P ordering. There is a reordering in which if you sort some things and apply XOR P, that is increasing. And if you sort some other things and then apply Q, that is increasing. And this claim is only coming from applying the fact that all these things are bigger than this, but we have more than that. See, you should always be able to see what you have logically applied, what you have not yet used, how you used everything that says in the problem. Because I'm applying that all these things are greater than that, but I'm not yet applying that this is bigger than this. I'm only applying this, and then I'm able to say that from sorted array, it's just few swaps, like few disjoint swaps. I haven't proved that yet, but I'm trying to see again that I have only applied this fact, but I haven't applied that. Also, this is bigger than that. These are bigger than that, coming from this being bigger than that, and them being bigger than that. Mm. So also, this is one more statement, one more thing. Maybe also that says something. One thing is very true, that P and Q should almost be similar. That is being obvious. They should be similar under XORing. They should be similar under XORing this array, almost similar. Because they are at max differing by some swaps somewhere, right? Should I go to next problem and then come back to this again? Or have you guys able to apply some logic? Are you from India, Magdon? Yeah, you likely are, I guess. I have seen your profile many times long back. I must steal these thumbnails. Yeah, I will try to come to that, but before that itself, I'm able to see there is something. I can't say if these people are serious or not serious because it seems childish a bit. What? Where are you doing job? Why do you want it that badly? I'm working at a startup as an engineer. Guys, we have some insights on this problem. So one thing I want to prove is if something has moved twice, can I disprove that claim? Okay, let's say something has moved twice, more than twice. For the first time, For the first time, something has moved more than twice. Okay, see how I'm applying logic. Things can be so complex, right? When something moves more than twice, the array will be very random. But if you see the first time something has moved twice, more than twice, then you have the array to be very structured. So that's how you apply logic, okay? So in the sorted array, the first time something has moved more than twice, we are looking at that. So this is the suffix where this is smaller than these two things, means it has moved twice to the back. Okay, now if this happens, you can immediately see that this is failing the condition that everything after that is bigger than lesser than bigger than that, that is being failed, right? So which says our claim is true. Our claim is true that the reorder, let reorder array be a, okay, and let's see a XOR p. This should be, let's see this as sorted one, okay, with just some swaps somewhere without moving anything more than twice in the distance, you can get the sorted array. You can make x or p sorted with just these things. Same applies for x or q. We have proved this very clearly. My claim is nothing has moved more than twice, and if something has moved more than twice, I will try to see the first time it has occurred. And if I see the first time it has occurred, because the smallest thing here has gone inside there, if you take this one, this fails this thing. And then see, 2600s are not this difficult. I used to get some problems. I'll get many very instantly. Maybe I used to get. Maybe now I'm not able to solve, but still I am making some progress definitely so far. Also, X or Q will be gotten by similar swaps somewhere. Are these the same swaps? We may or may not know it yet. I have only applied that. See, I have only applied that everything after that or greater than that. That's what I have applied. But we also have this being greater than this. Also, this being greater than this is also there. Okay? Dream on, dream on. Maybe it simplifies that. Also, this will have same things here and here. Maybe it does. But we have to see and prove it. What I haven't applied yet is I haven't applied that this is bigger than this. I have only applied that these are bigger than this. But what should I apply in general is this is bigger than this and this is bigger than this is what I have to apply. Are you guys discussing some other problem? I know you guys want solves But I have made some progress here. See, you have to try like this. Learn to try like this. Like I have tried so many times, I haven't gotten anything in 15 problems or so, and then maybe I have solved it after a few days. Maybe I have solved all of them after a few days. We have to try. Okay, here I was able to see. I have to apply that this is also bigger than this. Okay, now you have also this being bigger than this. Okay, let's try to apply the logic itself. Let's say so far the swaps are happening together, and here let's say swap has happened, uh, but here the swap hasn't happened. Okay, which means if you do p XOR q, these two, this is bigger than this, but p XOR q has this bigger than this, but p XOR p is having less than or equals to. And if you see this thing, maybe these two have been swapped. That may be possible, but these two haven't been swapped. These two have been swapped is what we are looking at. If these two have been swapped, this cannot influence this because swaps are only disjoint swaps, right? Okay, if they haven't been swapped and this has been swapped, that means this is bigger than this. Okay, I'm not getting very directly here. I'll read another problem and then I'll come back. You guys should be able to do this. Okay, let's try this problem now. See, it's progress. Trying to think problems is progress. I don't know why you guys don't understand that. Okay, some of you may be mad that I haven't applied XOR P, XOR Q at all. But first I want to implies and implies solve what this ordering means. Okay? Without even going into XOR. Unless I know that very well, okay, this is implies and implies this simplification, then I can think of XOR. XORing with P and XORing with Q. Because I feel there is some more things here to solve. Guys, follow focus on this problem. The fuck you guys are doing? I'll read this problem, I don't care. This is the easy version of the problem. The only difference between the two versions is the constraint on it. You can make hacks only if both versions of the problem are solved. You're given an array of integers of length n. In one operation, we perform the following two-step process. Choose an index I such that an AI equals to I. Remove AI and AI plus 1 from the array and concatenate the remaining parts. Find the maximum number of times that you can perform the operations above. This is likely some DP, but if you like it or not, you have to solve it, I guess. It's not DP, it's about the structure of the problem again. You want to choose an index I and then remove that and then concatenate things. Remove two things, you choose such that this is that, and then you remove two things. For something, number of things should be removed before that for it to go there. And number of things that will be removed is always even. Okay, this I can say. If there is 3 somewhere here, few things might be removed before that. Few things might be removed before that. Look at x comma y. Once y reaches y, you can remove that y. So for 3 to remove, only even number of things will be removed, right? I thought that I was dreaming. You said you loved me. See, it's useless if you guys don't try these problems. I don't know why you guys can't try the problems. Yeah, I haven't guessed it. That I haven't guessed that it's GP. I only said it once, and then I'm trying to see the structure of the problem itself. Okay. Hmm. In this problem, you can say that 3 should be in its parity itself, means odd values should be at odd places for them to be removable. But they can be removed because of something else that is there. So, one nice question you can think of is, for what type of arrays the answer equals to 0 is a nice question you can think of. You can apply logic in these problems, like odd is not in the odd, so odd is in the even. So before that should be an odd. We have F1 and F2. F2 is 26, F1 is less than that. See, this I have solved once long back. In stream itself, I have solved this, but I haven't implemented it. I can try implementing it now, but that's waste of a stream. Okay, these are 3000s, I guess. I remember that I have solved that. I don't have that much memory, but I have good memory. I remember that I have solved this in the sense that we solved it well. We solved it like by root of, I mean, it's like you take the lowermost thing of size 80, you take that subtree, and then you keep applying operations over there. Then that will come and catch up. It keeps coming above and above and above, and then you keep applying here, it keeps coming above and above and above, and then you can remove all these things with that. So what it means is you can do two kind of operations. Once you will ask if it is in the subtree at all, okay, and then if it is not in the subtree, you can remove the whole subtree. Then you will remove like 80 things at a time, and then you will find some other such subtree. And once you know that it is there in that, you can again come in that many operations. So it's like 5000 by 80 plus 80 operations or something like that. But I think we may need two times of operations at some place, so it's more than that. So first we can solve even with just this, and then I told for e2 you will further split this into 777 things. The 80 thing you will further split into 777 is what I have solved the problem. But the implementation is like, uh, maybe I haven't implemented it at that time for some reason. I remember it like how I have done it. Is that high? It's like I have done this after a lead code problem. I have done this. One lead code and one difficult code forces problem. I think that's how I have done that. Okay, this is total lead code. That's just 18 minutes. This is not in my home. Yeah, finding that now is unnecessary, I know. But yeah, this problem has actually been solved. This one has been solved. At least even has been solved by me. See, it says November 1st, 2025. This is November 1st. So we found the video, but what has gone on here? So this is the same logic. As long as it is in the subtree, you can do one more. So before it was in the subtree, now it is not in the subtree. Means before it has came here and now it has went there. So what would be u? You have done u means it came here and then it has went above. Why does it give idealness error though? See, there is no sin x here. Thought that I was dreaming when you said you love me. If this gets accepted, that shows how much I don't care about getting a solution accepted. Because I didn't even debug that after the stream. I just left and I just did something else. What's happening here? What happened, guys? Again, idleness limit. Okay, let's understand the code too. Oh, what the fuck is this? It was 212 and then it was asked, we asked like 2 comma 1 and then it gave 1 and then we just outputted 2 because it told mole was there. See, the problem is mole you will get the answer if mole is in this subtree or not, okay? And after that, it will move a bit above if the mole was not there. Let me read the problem. Uh, a hidden mole is one of the arrays. To find its position, you can pick an integer and inquire up to the jury next. The jury will return 1 if the mole is in the subtree. It will return 0 otherwise. If the jury returns 0 and mole is not in root 1, the mole will move to its parent. So if it is not there, it will move above. Yeah, that's the problem. And what have I done here? I got 1, which means it is there in that subtree. And then it won't move now because it is there. Okay? So output was 2, answer was 2. What have happened here? I queried 6 and then it was in 6 and then I outputted 6. What happened after that? Problem has been done right here. So what this implementation has done is it has divided them into subtrees, okay? And then it has pushed those subtrees here and then it has removed. I think I have done some good implementation, let's say. And then what have I done? Okay, there is something here. Find minimum thing greater than or equals to 70 of size 70, I think. Okay, this is about finding the subtree of size 70, I think, which has the mole. And then this is about pushing that subtree with respect to the sizes of the subtree so that we keep removing from below things. And then what am I doing? I'm removing here and then I'm checking the root. So V is the root, I guess. V is the root. I'll check if it has, and then I'll keep checking it itself. What is U though? I'm not able to understand this implementation. But at least we solved the problem. Let's move on to some other problem itself. I mean, we can't debug an implementation that was implemented long ago, right? How can we understand it? We have to solve it precisely. Okay, this is being clear. We're trying to find the smallest subtree that has our node, and then we will remove that, and then we will find that. Let me just run it locally to see what's going wrong. I keep removing things that are bigger size, and then I found something that has the mole, and then I'm operating on the mole. Why is nothing happening? Was this expected output? Okay, mine is being ideal. Why? What is trying to do DFS of 1 comma 1, and what does it do? It will just find. I can do O of n square. So each time I will find the whole sizes, and then what am I doing? I'm taking, if the first size is less than m, then I will break. So here we will break, and then we'll come here, and then I'm again doing the size. Now I'm doing get off subtree. Oh, oh, oh. Was this the error? Let's simulate the two test cases. Yeah, and then it's done. Now we have 6, 1, 2, 1, 3, 1, 4, 4, 5, 5, 6. It's asking about 2, okay? But the answer is in, I think initially it was in 4 maybe. We can keep anywhere we want. 1, 2, 1, 3, 1, 4, 4, 5, 5, 6. Let's put it in 6 itself, okay? 0. So 1, 2, 1, 3, 1, 4. 4 has 5, 5 has 6. So now it is in 6. Now it might have gone to 5. Now it has gone to 5. Now we're asking about 1. It is there in one subtree. So 1 is the answer. Now it is still in 5 itself. Now it's asking about 3. 0 and it has moved to 4. Now again it's asking about 1. It's in one subtree. But it's in 4 now. 1. It's still in 4. Now it's asking about 6. 0 and it has gone to 1. Now it is at 1. It's removing 5. 0 and it is at 1. It's at 1. It's asking about 4. 0. It's at 1. It's at 1. It's asking about 1. It's at 1. It's at 1. It's just removing one thing and then asking in the root. Remove, ask in the root if it's still in this array. Remove, ask if it's still in this subtree. Remove, ask if it's still in this subtree. Uh, if it has gone out, that means when you have removed it, it was in the root and then it has gone a bit above. And then when you have asked here, it has gone further above. That's why you are doing parent of u. I thought that I was dreaming, and you say you love me. See, in one we really don't test this code because this code is being less than 70 always in test case 1. In test case 2, this code will be tested. Maybe in test case 3 that will be tested. You guys may say this was done by me in the November and not the noob me right now. Because in November I was much better than what I am now, right? Actually, there the downfall has started. Even here I had similar downfall, October to November. You find all of them, and then what have you done? You found the smallest subtree of size greater than 70. This is quite simple. Find all the sizes and then find the smallest subtree whose size is greater than this because it exists. And then try to remove that. Now we have that subtree. That subtree has, you find the sizes again. Now you just got in the subtree. You know that there is in this thing. And then you will output the smallest thing you're outputting. The something that is in the below. And once you query that, if that is there, smallest leaf, if that is there, that's the answer. Else it has gone one above. So now you will ask root. And once you ask root, if it was root, if it is still there, you can repeat the process. It's still inside. But if it is not inside, what does that mean? When you have queried, it was inside. It was here. So when you have queried, it was here. Now that you have queried here, it might have gone above. When you have queried this, it was here. After querying, it has gone above. Now you have queried this, it has gone further above. So you have the answer to be parent of u. So everything's perfect so far. It is still here, so you remove that. Still here, you remove that. It's still in this subtree, and you have some leaf to remove. Okay, let's say this is the leaf. Then you will get one. What is going wrong then? Why idleness limit again? Feelings. See, the code is quite simple somehow. You're removing a leaf. If that leaf has the array, then that's the answer. Else, you'll again query the top thing. If that is not there, that means it has moved out of the subtree. And once it has gone out of the subtree, the feelings are running down. Can anyone see an error here? I'm trying to remove the smallest thing which is greater than or equals to m. Let me just add that for no reason. Last time I might have thought like that will not affect. Like I might have checked that logically that it won't affect. Okay, I don't know what's going wrong. Let me leave that again. Let me try some other problem itself. Why is it stuck? Time limit exceeded. Maybe idleness limit again. Let me read some other problem again. It's difficult to see the streams, I understand that. Let's read this problem and try this problem. You have an array of n elements. There are also q modifications of the array. Before the first modification and after each modification, you would like to know the following. What is the minimum length subarray that needs to be sorted in non-decreasing order for the array to become completely sorted in non-decreasing order? I have read this problem before. So it's like if you just see what are the positions that are in misplace, we can know the first misplace to last misplace is the minimum length subarray that needs to be sorted in non-decreasing order in order for the array to be completely sorted in non-decreasing order. More formally, you want to select a subarray of position or L comma R with the minimum value of R minus. I've read this problem before. So if you know the positions that are not equals to the sorted array, then you know the answer is just the first position to the last position. Note that finding such L comma R does not change the array in any way. The modifications themselves take place in the form A position equals to X for given position comma X. So we have queries. So here an array is being modified and we want q plus 1 answers after each modification. So how do you know that this is not sorted? The problem is quite simple, but how can you compute them quickly? What you should store to compute that quickly? It's quite hot. I'll wear some other shirt maybe. Feelings that are deep down. I don't care if any of you are here or not also because I don't think it's easy for you guys to follow or try. It feels time waste totally. The one obvious question is will you find the positions of the first non-matching thing and the last non-matching thing is one obvious question. I think most likely yes. Most likely we'll find those two positions and then you will subtract them and give the answer. But as elements are changing, how can you still find something that is not in its position? Let's say you'll always know if something is having just before thing before that. Let's say you always know that. If something is having just before that. Then once you insert something, many things might have to change. Actually, I have thought of this problem some time back during the contest itself, I think. Damn, Everrule has solved this in like 10 minutes, 20 minutes. Eve rule. Even Kira and Tyrovis have solved them. Leave that problem. Turtle just received n segments on a sequence A1 8 up to Sony, and the ith segment is Li and Ri. Turtle will create an undirected graph J if the segment I and the segment J intersect. Turtle will add an undirected edge I and J. The weight will be modulus of AI minus AJ. For every I not equals to J. Turtle wants to calculate the sum of weights of the edges of the minimum spanning tree of G, or report that graph has no spanning tree. Okay, for spanning tree to exist, it should just be connected, right? And you have weights described by A minus AJ. If you see from minimum spanning tree algorithm, they're even giving what does intersect means, because the problem doesn't need anything external, and we still doubt that it needs something external. Some of them intersect. You can see the segments, and maybe if you see the segments in increasing sorted order of or so on, like once you have this new segment that intersects with lost few things in the increasing order of R values. have less charge. You see, in terms of increasing odd value of odd values, once a new thing comes, it will intersect with some of this. So that's the graph's property, I think. So you have an ordering, and a new thing will only intersect with some prefix, some suffix is the graph's property that comes from intersecting, I think. We have multiple algorithms for MST. And now you also have like among these things you have some AI's value that are increasing, let's say, and now you have a new value that keeps forming increasing distances with these things. Feelings that are deep down. What are the MST algorithms you have? One famous thing is keep adding edges. And once, if it's forming in the same thing, you won't add that edge. If it's forming among different components, you will add that edge. So that's one algorithm. All of them are based on min cut. If you know that this is the minimum among all these things, then that should be added. Because if you don't add that, you can add that later, and then there will be a path connecting these two things. And in that path, there will be something bigger. So you can remove that and you can add this. So that's one algorithm. What's another algorithm? If you have a cycle, you can remove the maximum weight in that cycle completely. Why? Because if that maximum weight is present, okay, in the final tree, if that maximum weight is present, one of them is not present, I guess. Because if all of them are present, So one of them will not be present, and then you add that thing. Okay, this is the maximum thing in that tree now. Okay, can I say there is one thing among here that is present in where one is present on this side, the other is present on this side? I can say that because let's paint all this as green and let's paint all this as blue. Okay, now in this cycle, this will be green and this will be blue. Okay, so if you keep on going, there will be an edge which is green blue. There must be an edge which is green blue. Now you add that edge and then you remove this thing. In that way you can prove that in an MST maximum cycle edge can be removed always. Maybe we can use this algorithm. My charge is also gone. Maybe you can use this algorithm to keep removing the cyclic edges. I'm not at all solving, bro. I'm not at all solving. I'm just trying some things. I'm not solving. I used to solve more, I guess. I'm just trying to just solve because for no reason now. Because I said yesterday I will stream if I get 12 likes, I'm streaming. What about the other case? You can't keep adding smallest edges. That's even more complex because I think if you see the structure of the graph is having this will have edges with all these things and so on. And they have an ordering for the minimum things. Let's say you have removed all the cycles, all the maximum weighted cycles from here, and then you have that MST type of graph. Okay, now you are having new edges. Now you're adding these new edges. They will be added for all of this. Now you want to see number of edges that will actually form a maximum cycle among these. Okay, so if there is a cycle that has been formed, how would that look like? Let's say you have MST also. Let's say you have MST with no cycles until here. See, I should have reached red long ago. I don't know why I do this to myself. I want to do some other things rather than competitive programming, but for now, I'm just doing it. I'm not doing competitive programming. I thought I'll just do some 4 hour stream today and then I'd give a contest and then just sleep and tomorrow work or see about something else. Okay, when you have one more new vertex, what does that do? That keeps going on to all of these things. Right now, whatever the cycles that are formed, you will try to remove the maximum edge from that cycle. Is that easy? I don't think it's that easy. You guys can do something else and watch the stream parallelly, I guess. Or don't watch the stream, it's time waste, definitely. I don't see a easy solution here. Can I say something else with respect to values? Maybe let me try something, anything like divide and conquer idea. Let's say I have half of the segments whose R value starts later, and half of the segments whose R value starts before. And somehow I found MST among this, and somehow I found MST among this. Now you have these two components whose MSTs are known, and then you have many edges that keep coming from this side to this side, this side to this side, and so on. And now what you should do is, am I visible? What happened with? It's a dog nearby. Oh, why not? Like, let's try this one also a bit now. Like, you guys should be able to try difficult ones. See, I think even if I try 1700, it would be the same thing for me. Should I try some 1600s and try to brute force or speed force for a while? Let me read quickly and then I'll come back. Let me read some more problems quickly. Okay, this one I can see. Maybe some divide and conquer would work is what I was trying to see now. You have MST of this, you have MST of this. Okay, now you have edges coming from there to here. Okay, let's try to take them or handle them one at a time. Let's try to start from connecting this with these things. Okay, if you try to connect this with these things, this will be connected to all of these things. Are there any simple statements that I can say regarding weights? They have different things that are possible. Let's say for each of these weights, somehow the maximum weight. I used to solve these problems. Not this one, I guess, but let me read this now. I read this before, I guess. Will I get some air? To be better at physics, Anne wants to build an apple tree so that she can get hit by apples on it. I have read this problem before too. Her apple tree has n nodes and it's rooted at 1. She defines the weight of an apple tree as for all the pairs get dp of is defined as the number of edges on that unique shortest path from 1 to x. So you want weight to be either k plus 1 or k minus 1. For some n comma k it's not possible. Maybe there is a way in which you can always get k or k plus 1 or k minus 1, maybe. How would you get such a thing though? Is it like, are you sure that by 3 will become possible for everything? Is it something like that? Last time I haven't thought much about these things. I thought it's about k, k minus 1, and k plus 1, trying to see if all of them are possible or not. But maybe it is about reminder 3. Maybe by 3 is possible, so you know that either one of them is possible. The fuck is your problem? I think we can stream and try problems maybe. We have to just try it ourselves slowly because I'm not able to think at all somehow. Compute x plus 1, write x and x plus 1 next to each other in the decimal numbers with the subordinate in the resistance sort all digits in non-decreasing order. Okay, this seems little bit fun, but maybe it's not that fun because it's like digits, right? You want to compute x plus 1, you put in the decimal system without separators and leading zeros, and then you sort the digits. And then you want to know number of distinct strings among s1, 2, up to so on s of n. How does this pattern go? How does this pattern move? It's like s of 1, s of 2, s of 3, up to so on s of n. When will things repeat? S of 1 is 1, 2. S of 2 is 2. Okay. So S of I is just about frequencies, right? It's like just frequencies. Frequencies of zeros doesn't matter, and then it's about string, right? So frequencies of zeros also will matter. So it is so writing next to each other doesn't matter. It's about S of 1 is just nothing but number of digits in number of digits in x. S of x is nothing but number of digits in x and x plus 1. That's what it is, right? So that's one simplification, but that's an obvious simplification. Number of digits in 1 comma 2 is 1 comma, I mean 1 comma 1. If you see 0 1 2 3, so it's about x comma x plus 1 pairs that has same frequency of digits. Frequency of digits for x comma x plus 1 pairs. I thought that I was dreaming and you said you loved me. I have done much weirder problems long back. I don't know why I'm like this now. I just see the problems that I have done long back, maybe. This can be thought upon maybe a bit. How does plus 1 happen? X comma x plus 1, what's the difference? Let's say you have 99999 and less than 9 and some digits. You will have AGHW and then you will have F plus 1 and then you have 0000. Right. Otherwise, if it was just F and then something, you'll have BH W and WW F plus 1. So one thing is clear quite, which is these frequencies will be double and then these two will be the same. Right. So uh only you can always find the last digit. You can always find the last digit by identifying. See, these nines and zeros are also something, they also mean something. Hmm. 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 You can never say if these nines has come from here as 9999, 9090, 9090, or they have came from here. Right. Let's keep nines and zeros aside for a moment and then let's just only worry about these cases that doesn't have any nines or zeros in them. See, it's a logical problem. Like it's a logical problem in the sense you have to actually identify the structure of repeatance, like how they repeat, like what all possible combinations of x comma x plus 1 can match, and from that combination you will try to compute. Somehow you'll try to compute, and you will count them disjointly. It's a counting problem in some sense, but you have to understand the structure too before counting. Is my stream running? Try, guys, try to think about this. It's not bad to think about the problem. We have two cases. Let me just think about this one. In this case, let's say you're comparing two things of this format. Okay. In this format, all the digits are of even parity. See, the string is nothing but the sorted string is nothing but only frequencies matter is what sorted string means, right? So you have this all many digits having even parity, only two digits have odd parity, which will be f comma f plus 1. So if two things are matching, okay, if two things are equivalent, let's say, I will call an equivalence relation if I'll say x and y are in equivalence relation if it's written like this, right? X comma y are in the relation if they have same s of x, if s of x equals to implies and implies s of x equals to s of y, let's say. So this is an equivalence relation and we only have to compute number of equivalence classes. So I'm just trying to see x's in an equivalence class of the format where last digit is not 9. For some reason, let's try to see that. Okay? If you try to see that format, this class can be qualified as f, f plus 1. Only two things. One of the class can be qualified as with f comma f plus 1. And then you have many possible arrangements that you can arrange these things as that their values are less than or equals to n. would be the group size. But how many groups will there be? Is it a smaller number, or is it a very big number that you can't go over? And if it's a big number, maybe some groups are small and some groups are big. Maybe one thing you have here is you have this and this, and you have number of ways to rearrange them. Number of ways you can rearrange them such that both of them should be even. So which means uh for this and for this and for this, you can just divide their frequencies by 2, and then you can just try to see what all possible arrangements you can do such that the value is less than n. And I'm just trying to see one group size, one equivalent, one class, like what would be one class's size. Okay, and then there are cases with odd number of nines and odd number of zeros. If an 9 is odd, that means there were odd number of nines at the end and odd number of zeros have been formed. But then there can be 0 and 1 here, making zeros again even and 1 odd. I think the problem's level of difficulty has increased these days. Before, 2600s were not like this, I think. I used to do 26 to 28, keeping all of them as equal level, like thinking all of them were like equal. I used to do 29 to 32, but I don't know what happened to me now. I've been showing that I was doing, but I never was, I guess. I think that's all it is. I've never done more. Okay, here I have done a bit more. Oh, here I have done actually more. I've liked all of them. I liked pairs of pairs more. I've shown that multiple times to people. One thing I can say is whenever I have solved them, I like them a bit when they're in a more difficult rating. I don't know what's happening. Now, why do they appear so difficult? You have many different ways to reorder them, and then you have those groups. Maybe can you see for a number if it has appeared before? This simplifies the problem a bit, right? What is a good number? Now, a good number is something that has not appeared before at all. Means there is no way that you can rearrange these things such that it is not something smaller. I think this seems to have some way ahead rather than these groups, because the groups can be many, but maybe we can count the number of good integers somehow that has never appeared before. Because if you see this thing, okay, if you see this number, what is a good number among this? Let's only look at this type of things. What is a good number among this? Thought that I was dreaming when you said you loved me. The start of nothing. See, these are always bad. Because if you have this thing, you can put them as. Let me be more straightforward with what it is. See, why am I trying to do is I want to think deeply like how I was doing before. Yeah, I'm only vibe coding now. I don't think level has increased. I don't think it's like that, but even if the level has increased, I was solving 3000s and 2900s also, right? So it doesn't make sense that I can solve 2600s now. See, I don't care about rating also. I get back my solving difficult questions ability because that means something to me, I guess. We have 9999. This can be made into a bad thing just by. See, these things I was worried about, but they are always bad. Why? You can take these six nines and then you can just put them like this, which will be smaller numbers for sure. And then you can take these zeros and then you can put them like that. So these are definitely smaller numbers than them. So these are always bad, most likely bad. So if you're trying to count good ones, they are either of this format or of this format. But even in this format, okay, if this was even, then all the nines are inside, all the zeros are inside. So the only case I was a bit worried about was this case, right, where they are even. But if you try to count good ones, see if they have structured the problem in a way such that let's call an integer good. If its frequencies have never appeared before, then the problem is much easier. Because these both are exactly the same problems. Like try to count something distinct, you can count it by telling something that doesn't appear before, you call that as good, let's say. So now it is just number of good. But somehow if they have stated the problem in this way, it might have been much easier. Not Fen. I like Fenwick tree actually. I use that whenever possible, rather than. Okay, 29s. How many I have done? There are only 3 pages of them. Odd queries on an odd array. Only 333 solves. Yeah, this was a good one. I have done it on contest stream itself. Decent. This is stop gaming. It's about a prime, I guess. No, it's not about primes. When did I all this? The fuck is this? Hmm. Okay, I remember the problem. Also, Satyam has done this in contest itself, I guess. I remember it a bit. I think it's not that difficult. There is only one small thing between E1 and E2, I think. This sounds good. Vertex pairs. Damn. Maybe here I was cooking. This is the prime number thing. I remember cactus not enough also. It's like some ICPC type problem with a cactus definition being a cycle on a cycle or something like that. This was that good problem, lost number, which was much more complex. It because rainbow solved it, it's 2900, else it is 2034 or something. But yeah, we are able to solve this one now. We are almost very close to that because this has been simplified. I think it's being hopeful and being trying to see what can be simplified because this is simplified. These two can be simplified by this. This definitely doesn't exist because they can be transformed to, they can be transformed to 999999000000. These are definitely smaller, and so these things will never be bigger than them. If you have 99, wait, they are of equal size, but if you see that, wait, maybe they're of equal size, but instead of this, let's put them like this. Okay, now you have to fucking compare these two things. F99999 versus 000999F. Even if there was one nine, even if there were two nines, means you have 0099 and 009. 09 is greater than. You have to compare from here. My bad. To compare F99999, let's say even number of nines with 000F 000999F. To compare these two things, this is smaller. For I thought that I was dreaming when you said you loved me. The start of nothing. Ooh, I can hear you now. Okay, this works if there are six things. What if there were four things? Even then it works. Because even if f is 0, this is smaller. What if there is only one nine, two nines? In this case, if f is greater than 0, this is smaller. But if f is 0, then this is smaller again. So in all the cases where it is even, good numbers will never have anything after that. Good numbers will always be in this fucking format. And when they are odd, then you have to worry a bit because here you have f plus 1, 9, 0. All of them are having odd parity. If all of them are having odd parity, then you have to worry a bit. It's either 0, 9, two things in between as odd parity, or f matching with this, or f plus 1 matching with this. In that case, also you have, only in that case, in these two cases, you have 0 matching with 1, you will give you 1 comma 9. So you can have 0 f plus 1 9 in odd parity, or you will have 0 1 9 where 0 has gone because f equals to 0 case, or you will have 0 8 f plus 1 equals to 9 case. In most of the other cases, odd numbers are just f comma f plus 1. I thought that I was dreaming when you said you love me. But all of them are disjoint, right? This can never match with this, can never match with this, can never match with this. F and f plus 1 are also disjoint from these two things because they are not f and f plus 1. So these are the four formats you have for good numbers. And you know, those good for these good numbers format is something like this: f9 f plus 1 comma 0. These good numbers format is ooh, I can hear you now. Their format is 0910. Okay, and their format is obviously 8990. And their format is just the most basic format you have. See, this is the most general case where you may have nines also, but then we proved that multiple nines is useless. Only odd number of nines, only one nine is useful in the end. So now we came down to only these few formats. Either this format or this format or this format or this format. Good numbers will only occur in these formats. I thought that I was dreaming when you said you loved me. So now let's think about the simplest problem. For this format, we want number of good numbers less than or equals to n. Okay, and this thing should be in sorted order, but also they may have some zeros, and when they have some zeros, the leading bits also will add something in these cases. So you come in the start of nothing. Ooh, I could hate you now. So guys, we have to let's think a bit more on this case. Okay, see, zeros cannot be leading because we remove leading zeros and then we come back concatenate, but zeros can be present. So if zeros are not present, then it's just some ones, some twos, some threes, some fours, some fives, some sixes, and so on. So these are the good numbers because these are the smallest numbers, right? Even in this format, even after you moved all the nines before, the easy simplest format is this one now, right? Ooh, I could hurt you now. Mhm. So you want number of these values that are present with f values less than or equals to n. You want number of these type of things that are present with less than or equals to n. Okay, which is nothing but you can just move this f on that side. It is n minus f, and then you can divide by 10 too, and then you can just have it like number of ones, twos, threes, fours, number of ways you can place some ones, some twos, some threes, some fours, some fives, and some sixes, such that The values are less than or equals to n. I thought that I was dreaming when you said you love me. So that's an actual problem you have to solve maybe if you're splitting things like this. So you're going somewhere. So this, I think this is definitely the way forward. You should be able to count these things. Number of ways you can keep this number such that they are less than or equals to n. Less than or equals to some particular number. I think that makes sense. That's not that difficult. If you see, this problem is not that difficult at all. You have a number, you send that f that's you divide by 10, and then you have some number n, which looks like this, okay? And then you want number of ways you can keep some ones, some twos, some threes, such that the numbers are less than that. One thing, if the number of bits is less, if the because of f we have uniquely split them already. If the number of digits is less, then it's obviously smaller. If the number of digits match, and if it is already less, you can just have anything from here again, okay? And then if you start with 2, anything from here again, okay? But now if you have started with the 3, the number 3, you can only go to 3, 4 up to so on, right? Then you will think about the next problem, next one, okay? From there, let's start from 3, 3 less than 5. So you can have anything from here, okay? And again it means 3, 4 is also anything from here, and then you will come at 3, 5. And then if you say 3, 5, 1, anything from here. So it's being quite simple, like the pattern is quite simple, I guess. 3, 5, 7 is also anything is possible, and then you have 3, 5, 8. It's like just increasing digits that are coming. And then when you get a smaller thing, I think then it breaks. I'll go to washroom and then I'll come. Maybe I'll think. I think there is not much to think here. This problem is being solvable. We have to apply small logic on everything. This is not big logic, right? This is a small logic problem, like, but you have to apply it here. You have to think carefully, and then you have to maybe do it. At least I can. I think at least we can solve this one. I want to answer such questions. You stay alone. I have friend nearby, but yeah, I stay alone. So guys, this is being done. You guys can think of other cases at least. It's just that you don't want to think. You guys can think of what happens when there is a zero present. When there is a zero present, the pattern is three three threes, zero zero zeros, four four fours, five five fives, and so on. Why? Zeros can be leading, but they have to be present. And you know number of zeros that are present. Then what you do? You first place the other thing. So this is some other pattern. So it's like a very difficult brute forcing thing. And people at top can also solve such shitty problems quick. I'll go to washroom and come. I'll carry my phone, so we never know how long it takes. I'll just play chess sitting there. Thought that I was dreaming, I knew that you loved me. Still has nothing. Hi guys, finally we have actually solved a problem. Do you guys see that? I came back. Do you guys see that we have actually solved a problem? You can keep trying with your teammates. So we have solved this problem at least. Like it was quite direct to be honest. And if you think about the different use, the different cases that we are seeing, okay, this case is nothing. It's the same thing. Like it's same as this. Instead of f, you just subtract f9, and then instead of you subtract f9, you subtract 09, you subtract 89. But you subtract these things as distinct things. You subtract f9 and then you 1 minute. So you subtract just f9, you subtract just 009, you just subtract 89. It's just same as f9, and then you just find the answer for this thing. Like here it's very obvious that if zeros are not present, you try to count number of these things, and if zeros are present, you try to count. See, we are either increasing the number here or we are matching onto this side. So it's just of 10 plus 10 at max. As we move this side and this side. And if there are zeros also, I think the same logic can be applied. So initial some ones can be there, some twos can be there, and then anything. Ooh, I can hear you now. But here you must be careful that at least one zero should occur. Maybe the format is always this one. Maybe the format is always this one, but sometimes zeros can be none. So maybe the format is always format is always x zeros x plus ones and so on. So if I just consider this format and try to match x, I thought that I was dreaming. So for one, you can just start with. Now you have to start with ones, zeros, and so on. Number of such possibilities. For twos, zeros, and so on. Twos can be non-empty, zeros can be non-empty, and everything also can be non-empty. For 3 comma 3, now it's about some threes, zeros, and so on. If it can be anything in a sense like this. But for this, You can only have fours, fives, and so on is the format. So there are two types of formats. Start with X, 0 not allowed at all. Start with X, 0 is allowed. That doesn't mean 0 is necessarily there. I can try to count with respect to 0 is definitely there, but I think that's more work for us than counting in the other sense. See, this one is solved at least. Like, are you guys, why are you guys are not interested? Like, this problem has been solved. It's 26, but it doesn't have anything in that. Maybe other problems are also like that. I'm not getting them most likely. This actually doesn't have. Maybe it's educational. That's why it doesn't have anything in that. It's like brute forcing. See, if you solve this one, all the other things are also same. You just subtract 0, 9 and then divide by 100 and then you find the answer. Subtract 8, 9. Use the same function to find the answer. So the problem has been solved. If I just solve this one problem, okay, then the problem has been done. When the digits doesn't match, it's easy. See, when digits doesn't match, it's easy. You can separate things into zeros not being present, and then you have ones, twos, threes, all of them being non-negative, which is easy to count. You know how to count that. When zeros are present, you have a zero here, you have a one here. 1 0 is already there. You can add some ones if you want to, you can add some zeros if you want to, you can add some threes if you want to, fours if you want to, and so on. 2 0 all already there. If you want, you can add more twos in here. Wait, it's not ones and zeros, it is one zeros. The format is 1 0 and then ones, twos, and then zeros, ones, twos. Two zeros, zeros, ones, twos. Wait. Now, if this one was present, that one would have been here. Zeros, twos, threes, and so on. 3 0 and then zeros. See, it's about how you count things disjointly. Like all counting problems are about that, right? How do you count things disjointly, like without recounting them? Yeah, I will give contest. But can I? Do you guys think I can implement F and get it AC? I will come to 900 and then I'll show you practically how to get out of that. I'm quite close. See, in this format, you want the smallest number with these frequencies that hasn't appeared. All of them will follow the same logic as this one. Okay, and if I'm looking at this one, if the number of bits is less than, if the number of digits is less, then you have number of digits less, and then you either start with no zeros at all. No zeros means ones, twos, and so on. If number of digits is small, this is just the way, and counting this is not difficult, it's quite easy. It's like n plus r minus 1 c r minus 1 thing. And then in 10, 20, 30, for all these cases, it's again quite easy. From zeros, you have to just count zeros, ones, twos, zero ones, twos, zero twos, threes, zero threes, fours. Okay, and then you will count all of them. This I'm talking if number of bits is small. Okay, if number of bits is more, then how will I do this? If the number of bits is equal, then how will I do this? Here I'm showing how to do it, but how will I do it if number of bits is equal? Let's think of no zero case. Now, you can start with 1 if you are looking at no zero case. Or you can start with these things. Okay, if you're starting with these ones, if you're having 1 here, you can have anything here. If 1 is less than that. And if you're having 2 in the first digit up to so on, if the first digit is 3, and then you can have 3, 3 if it is less than that. So you will try to extend as long as if it is less than, you're done. Okay. And then here, when it is equal, you'll try to extend further. Okay. Because you cannot increase this, right? You cannot increase this further. So you will extend. And then you will see 351 to 357, all of them can have anything here. But 351 is not possible, right? So you'll have 355 to 357, everything is possible. And then you have 358. So you have 3588 because the next thing is also 8. And then you must have 8. So it failed here. So it's impossible from here because this is a smaller number. And this is the answer. How do you code this? Like it's simple, like it's a simple pattern, but how should I code? Should I use something recursive or should I just count them digit by digit? I'm thinking about implementation. This is easy. This is easy. This is easy. This is easy. You have 4s, 5s, 6s, 7s, 8s, 9s. So this is all like n plus r minus 1, c r minus 1. You can use from force. Okay, now think of the other cases. 1, 0, 1s, 2s, and so on. Think of the cases where it matches 3, 0, and then 3, 0 is matching. If 3, 0 is greater, then it failed. See, we are trying to disjointly split them. Start with 1, start with 2, start with 3. But for 3, start with 3, 3, start with 3, 4, start with 3, 5. But for 3, 5, we're splitting it further. Start with 3, 5, 5, start with 3, 5, 6, start with 3, 5, 7. So we're splitting all possibilities into this. So everything is being covered. Okay, now for 3, 0, you have starting with 3s, 4s, and so on. If this is less, you can keep anything you want. If that is matching, then you have to solve the problem again. Starting with 3s, you have to solve the problem again. Starting with 3s, you have to solve the problem again. So I think let's define this like this. You have some number above here. Starting with 3s, because 3 0 is also being solved into this, right? But there can be some more zeros here. I'll just brute force number of zeros, let's say. I'll just brute force number of zeros. And then it will be like 3s, 4s, 5s. Because we can brute force number of zeros, it's like 90 into 98 max, like 9 into 98 max. Yeah, just 10 power 4. 9 into 9 into 10 power 4 works well. If I brute force number of zeros, now it is just 3s, 4s, 5s, and so on. If this is less, then you can keep anything here. If this is more, it's failed. If this is equal, then starting from 3s, you have a number of different ways such that this number is less than or equals to that. So let's say that is your problem. How can you reuse that problem again and again? So starting from once, the problem is this. So what would you do? You will try to compare the first number with the first number. Starting from once. Starting from threes also it might have been in this case. Then what would you do? Okay. It's quite simple now. We'll try to compare x with the x. It's quite recursive. We can use, yeah. I mean, most of the things are recursive if you try to see them, because if I define the problem in a way that, okay, starting from x, what's the problem? Once you go from 1 to 2 itself, it's x plus 1's turn. So you can think of the same problem using x plus 1. Okay, starting from x plus 1, what's the answer for this now? See, I'm removing zeros entirely by brute forcing that zeros, and then I have ones, twos, threes, up to so on, threes, fours, fives, up to so on, all that time. Starting from here, number of ways you're less than or equals to that is the problem now. So it's quite simple. We have solved the whole problem. Can I implement it in 30 minutes and then sit for contest and still speak straight for hours? So given a number of ways to match its digits and start with ones, twos, threes, and so on. See, ones can be 0 or more. We are not keeping any restriction on that. Okay? Am I visible? Oh, we have some no's now. It's likely no, because how can I solve so quickly? You guys should work out too and have muscles and abs like this. Oops, where am I going? And get goals too. Don't just be a nerd. Even though I am here on a Sunday streaming, I'm voluntarily doing that. Okay? It's not like I can't go out with any girl. Where am I? Yeah. Okay, now how will I do? Starting from x's, like let's say The first number is x. Then the problem becomes, if x is greater than that, it's impossible, and then it's done. 0 is the answer. If x is less than that, you can keep anything starting from here. Upper limit is not there at all. Number of ways. So that's one other function for us. You have to fill these many digits starting from this. How many different possible things you can do is a different problem. Okay. That problem will be solved with this thing. Okay. Now for the remaining problems, if that is equal, then what do? You will go to the next place starting from ones. How many different things is there? It's one answer. Okay. And then everything starting from ones is done. You have recursively solved the problem. And then you go to see starting from twos, because starting from ones means will also involve starting from twos, right? So you will call the same function and call it from twos. And if it is nines, you won't call the same function again, because 9 plus 1 is not there, right? So this recursive function has been done. And then 1 zeros, I will just brute force number of zeros. 2 zeros, I'll just brute force number of zeros. And then I'll call the same function by seeing if this value is less than that or greater than that or equal to that. Based on that, I'll just call the same function by telling starting from 1, starting from 2, starting from 3s, and so on. Okay, and what about the case where you can keep anything? Those cases will be solved by taking number of possibilities, like number of possible values you have. Let's say like ones, twos, threes, up to so on. How many possibilities you have and how many digits you want to fill. Based on that, I can have a function that just gives me n plus r minus 1 cr minus 1. So now I have many things. Like, let me formalize, let me make the plan a bit and then just solve them. Get using these many digits greater than or equals to 0. How many ways to form d digits? D length. Okay. You have k digits, you have d length. How can you do that? So this will be one function, and then this will be one function, and then this will just be using that function. Okay. I'll just name it any pos k d, return ncr of so you have k digits possible. Okay, and let's partition d things into k minus 1 partitions. If you add number of things that fall before will go to 1s, 2s, and so on. If you have k things, d plus k minus 1, you have to just choose positions in that. CD. The thing is, what are the values of these things? At max, the factorial will be n factorial will be d plus 9 plus 9, let's say 18 factorial. 1e15. So I think it works if I just use long. I know this is the stupidest way one can write. We have better implementations. I know that. So let me just go with that then. N into n minus 1 into n minus 2 by 6 is n minus r plus 1. Okay, two of them are done. This will take an integer n, okay? And then it will take some integer x. This doesn't care about zeros. Zeros doesn't exist here. And then it will return starting from x number of things you have. Okay? You want leading bit of n, or nothing much. How do you get leading bit of n? Get its 10th power maybe. Maybe it is existing. Power 10. What is it called? Units place, tens place. Level 10. Stupid names. Would this be done? Would this be correct? Like number of digits you have, you remove this digit, you remove this digit, you remove this digit, you remove each of them digits, and for each of the digits you are trying to multiply 10, 10, 10, 10, 10. Maybe I have to do p10 by 10. With a single digit, it's gone. You have that. So I'll just find its level, okay? Okay, now we have this digit. You can just get that digit by dividing n by p10. If x, okay, start digit, like let's call it s, start digit, n by p10. S less than x means return 0. Can't do anything now because it's already bigger. You can start from here and then if x equals to x, else okay, if x less than s means okay, all these cases you will try to do them in two ways, I guess. Start with x, And now x plus 1. I don't feel good today. I am sick a bit. Stomachache, I guess. Now, what should you do? Start with x. X is less than or this, right? If x less than s, you're starting with x, okay? But x is already less than s, means now you have start with x. How many digits do you have? I think getting number of digits is better. This will give me number of digits. This will give me p10 back. Now we have number of digits. In this case, it's just one. You have put x and it's done. Nothing else to keep after that. And now there are some digits here, okay? You have placed x here and it's already less. And you have some digits, you can start from x and then you can place. So how many digits you can place from here? You can place x, x plus 1 up to so on 9. Okay? 9 minus x plus 1. These many things you can place here. And you have d minus 1 digits. Answer plus equals to, I placed x here. From x you have this thing that is nothing but get any pos. I don't know what any pos means. K comma d minus 1. Oh, you need not do reminder because all these values are small values somehow. And then now x plus 1. You have another case. Else, see, if x is less than x, x equals to s here. Now you gotta go to the next digit again. I think n equals to 0 return 1 will already handle it because so far it's been good. So n equals to 0, have nothing to keep. Starting from x, you can just leave it empty. That will handle it, but should I again add a god here? I don't know. Now we have to solve the problem for n minus equals to. Now we have to solve the problem for. You have placed x here, which is equal. So now you have to again solve the problem further for n minus p10 times of s. You're just removing the first digit, comma x. You can start from x. What about here? All the digits are done, which is nothing but it is 0. Here it is non-zero because there's one more digit. Here digits are done, which means 1, just 1. Even if I have done it common, it would have been 0 and I would have just gotten 1 back. But yeah, I'm writing it like this for now. So this is done. As it becomes 0, it ends. As it becomes 9, as x becomes 9, it ends. Each digit is being stripped away, x is being increased. Either x is increasing or a digit is being stripped down. So digit has been stripped down, x has been increasing. So yeah, the progress is definitely there in one cycle. So is the problem done? Nah. This is only one function that says start from here and then that just answers that one. So now you have to write another function that just takes any number n and then finds all possibilities for that. Okay. I'm not able to name things. Takes a number n, tries to find all the things that are possible with that. Okay. Number of digits being less than that, number of digits being 0. Fuck. Number of digits being 0 also is there, huh? Thought that I was dreaming when you say you love me. The start of nothing. Ooh, I can feel you now. When number of digits is 0, you would have a unique case 910 where you have 191110. That doesn't occur anywhere else. Let me assume those are non-zeros, okay? And when these things are 0, this is unique, this is unique, all of these are also unique because they are the most basic standard versions, right? So for them you have to just check if 9 less than n or 89 less than n and f less than n or not, less than or equals to n or not. So let's assume these are non-empty so that this complexity will remain here itself. Can hear you now. Okay, if the number of digits is less, you have I digits. You can start from 1 without zeros, I'm thinking. You can start from 1, you can start from 1 means like answer plus equals to any pause, anything is possible. And you have 1 to 9, which is like 9 digits. And then you have I things that to be placed, you can place as you like. Then you have the answer, and then you have to think of matching digits one. Okay, if you're only having ones and not having any zeros, I thought that I was dreaming when you said you loved me. The start of nothing. Ooh, I can hear you now. So now I will just make start digit equals to 1, s less than or equals to 9, s plus plus, and then I will keep number of zeros after that equals to 0, I less than d minus 1, I plus plus. Okay. So why we have d digits in n? I'm placing something here and then I'm brute forcing on number of zeros. S I zeros. And what would be the position of this thing? Think of that. You have 1 plus I digits here, total digits here. So it is d minus I minus 1 digits on the right side. So if you power that, p, I'll just keep it p equals to power 10 of d minus I minus 1. I want I plus 1 to be less than or equals to d. Now you have again cases. You have now you have to just compare 2000 with the n's prefix. How would you do that? I'm removing these things, so now this is n and this is this, and what is the other thing that you want to compare? S times of power 10 of d minus 1. You have to compare that with this n temp equals to n temp. If this is less than that, that means the other digits, d minus I minus 1 digits, they can be anything they want. Okay? And if they can be anything they want and they start from s, 9 minus s plus 1 is that, and you have answer plus equals to not fun any pos of k comma rem. I can just make if rem equals to 0 return 1. I think I can just do that instead of writing these many times these many things. Fine. If they're equal, what should you do? You have to just remove the prefix and then you have to solve the problem. Right? M minus s times of MSB is what that is. And then you have to solve it for. Thought that I was dreaming when you said you loved me. The start of nothing. Ooh, can hear you now. Nah, it's being a bit more complex. If all of them are zeros, then zeros doesn't mean you came to the end of the place. Zeros mean you should have values less than or equals to 0. Fuck, this is a bit wrong. N equals to 0 returning 1 is wrong. I will pass digits also. I can solve it right now, I guess. I'll just stop and I'll give contest. Maybe I needed better implementation. I don't know. Bye, guys. Thanks for being there. Good luck for the contest. You guys can leave, I think. Bye. I will end after three hours, but you guys can leave. I think it's been 4 hours already. 3 more minutes. You guys can leave and prepare for contest, I guess. Maybe I'll score it after the contest. It's shitty implementation. Not that shitty though. It's about you. You can make implementations better. I should have seen it like rather than number n, you have these digits and then you have to make things less than or equals to that digits. I thought that I was dreaming when you said you loved me. The start of nothing. Ooh, I can hear you now. But anyway, I handled one cases already here, right? If number of digits is greater than 0, only then I'm doing that. So maybe it's already handled. I should just check that after this, if rem equals to 0, answer plus equals to 1, else there are some remaining digits, okay? And then you have remaining n. Now this should start with a leading digit. If it's starting with 0, it's impossible. It should start with a leading digit. That's the complexity, right? So now it's starting with the leading digit. Yeah. So now my function n, f(n) of n, will always have a leading digit. Okay. Even here I have to make sure that it will always have a leading digit. This doesn't fucking work. Yeah, it's obviously wrong. So I'm gonna start end the stream, start a new stream, and do that.